Hey guys, it's JD from Eastwood, and in this video, we are going to learn how to TIG weld. Joining me today is Mark R. He's the R&D manager here at Eastwood, and basically, he's the guy you want to go to if you have a question about TIG welding, so he's gonna teach us today how to make them pretty. Now Mark, before we dive into the actual technique and how to do this stuff, let's say I'm the new welder, I'm looking to buy a machine. Where does our Eastwood machine sit in the market?
Well, that's a great question. So you got the industrial, you got your Miller and Lincoln out there, $3,000 to $4,000. Those are the workhorses.
That's true, but way too expensive for the home gamer.
Okay, agreed. Then you end up with the Eastwood unit here. This one here, we got you got the flex head torch included, you got the gas lens, you got the flow meter, and you got the large rocker style pedal on there.
Yeah, and also I believe the warranty is, if you buy now until 2022, it's going to be doubled, 6 years rather than 3, right?
Yep.
And there's also free shipping for the holidays.
Correct.
Spend over $200, you get free shipping as well. So really a great value proposition with the TIG 200 AC/DC.
Yes, it is. Then you got a prosumer level down there where you have the prime weld. You got them out there.
The prime weld, I think that's over 800, 3-year warranty, but no gas lens kit included in that one?
Correct.
Right?
Out of the box, no. Okay, so then you have Everlast.
Okay.
Everlast is a good unit.
Everlast is around 800, 5-year warranty, but that one, no gas lens kit,
correct,
no rocker pedal, and no flex head torch included.
Correct. That's all additional accessories, yeah. So let's lay down some welds, and we'll show you why this is the best value on the market.
Right on. Let's get to it.
So you just saw a TIG weld with steel in there. So let me show you how we got there.
Okay, first thing we need to do is clean the piece, right? Vitally important to have a clean piece of metal.
Mechanical, acetone wipe, and then you're ready for the welding itself. Personal equipment, helmet, gloves, jacket, no exposed skin.
You don't want any suntan from the TIG weld, right?
Yep.
Good helmet. I see you have a cheater lens in yours, right? That's a nice touch as well to get nice and comfortable.
And that helps a lot for me.
Yeah, yeah.
Tungsten prep, anywhere from 10 to 30 degree on there. And keep it sharp, keep it clean.
Right.
So as you're welding, you dip, you touch, stop, and don't try and power through with a dirty tungsten.
Now, for the people out there that don't know, why wouldn't you want to use a bench grinder, and why do you need a dedicated tungsten grinder?
The best thing on there is tungsten grinders, you got a diamond wheel. Bench grinders, you could have an aluminum oxide wheel in there. So now you're taking aluminum oxide, possibly contaminating your tungsten itself. So dedicated is the best. Stick out, we're using a gas lens here, which is included with the unit.
So that helps, right? That cleans up the gas flow a little bit, gives you a little bit more wiggle room in the shielding atmosphere. Also
gives me a little bit more stick out. If we're doing any tube work, something in there, I run about a 3/8, as you can see there, comfortable. Get in a position where you're comfortable on the bench. Nothing where you're out of position. The other thing is then holding, about 15 degree with the torch angle. You can go ahead for practicing. You see I'm not even moving my hand at all. I'm just moving my wrist.
All on the wrist.
Or you can practice sliding. Whatever's comfortable. Focus on like a 2-inch bead as you practice, so however you want to do that. And then we'll go ahead and introduce some filler rod in there. So what we can do now is just run a couple puddles. We'll just run some bead there and get some puddle control.
Gotcha, gotcha. So for practice, you're saying run a couple fusion welds.
Yeah.
Also, I've seen if you take a sharpened pencil, piece of paper, you could push a washer around, and when you're at the point that you're not drawing on the paper, that's pretty good. Usually a pretty good. And that's
a good point.
Up and
down. Is distance to substrate that you're talking about in there. You want to have your tungsten as close as you can without touching your substrate in there. About a 1/16 off of there is good.
Gotcha.
So puddle control, #1 thing in TIG welding. If you can control that puddle, you can do any of the welding in there. So that's what we'll just work on there, is just moving that along.
Gotcha. Well, now that we've gone over some of the basics, can you show us some of the stuff that might go wrong if you're just learning and starting out with TIG welding?
Yeah. So the #1 thing you're going to run into is gas flow. Either the wrong gas, bottle's not on, or just not set correctly. So let me show you what that'll look like at home. Nothing. So I got the high frequency, but no arc at all. The reason, bottle's turned off. So let me turn the bottle on, and you'll see the difference. So now, there's my arc. So when you're welding and you get into that, like it's not the machine. It's all you're hearing is the high frequency in there. It's not that. It's that. Always check the bottle.
Right.
And check your regulator settings.
Gotcha.
Or the flow meter, as with this one. Comes with this.
So this comes with a couple of things, right? The TIG 200 AC/DC that help clean up the gas flow and make it a little bit easier to control, right?
Correct.
You got your gas lens kit that cleans up the turbulence as the argon flows out of the torch, and basically gives you a nice bit of shielding atmosphere to work with, make things a little bit easier. And you also get that flow meter, a little bit more accurate than that standard diaphragm gauge, right?
And it saves gas.
And it saves gas as well, which ultimately saves you money in the long run, right?
Yeah. Yep. All right, let me show you another common error that's going to happen.
Okay.
So we saw what happens with no gas flow or not enough. So we corrected that. We have our sharpened tungsten. The next thing is tungsten height to substrate and varying of it.
Okay, so you're talking about too far away, torch angle, that type of thing.
Yeah, so what we want to do, about 15 degree with the torch angle, keep it, again, about a 1/16, as close as we can to the substrate, and keep it even. I'm exaggerating here, but that's what you're going to find, especially when you're welding a little more out of position or on the vehicle. You'll tend to go like that. So we'll show you what's going to happen when you're too far away, and then you'll know what it is, too close.
Okay, let's see it.
So there you go, correct torch angle, got my puddle established. I'm moving that along. Now here's what it's going to look like too high. You start wandering.
Right, you get that big funnel. It sort of walks around. You're getting some sparks out of there.
So I'm coming back down.
Okay, so that's normal.
That's
How about you show us the third error, Mark? Too close.
Too close. This one's going to be obvious for us, but here we go.
So that's pretty obvious, right? I think our tungsten is contaminated at this point.
Yeah.
Yeah,
so
that's going to be a resharpen. And this is really where the practice comes in, where you're pushing the washer around with a pencil or just working on your wrist movement.
Yeah, and it's exact. Yeah, you get, you know, don't worry about the filler, nothing with the other hand. You get that puddle established and then just start slowly coming across there. It's really what you want to do is just practice keeping that puddle the same diameter, same depth.
Yep.
Coming right around.
Yep. So what about our fourth error? Let's talk a little bit about amperage.
So amperage, what you want to do, the rule of thumb on these machines or any is about 1 amp per 1,000th of thickness. So
now going off that, that's an easy rule to follow, but I know people like to run a little bit hotter.
Yeah.
If you're the type to move fast, a little bit colder. What do you prefer?
I go the other way. I go a little bit colder because I weld slower. With corrected vision here, I need to go in there slower and do that. So I tend to go, so for 1/8, it's 125 thousandths. Set your machine 125. I'll be down like 110.
Personally, you'd back
I go a little bit.
Yeah.
Some of the seasoned pros, they could run a little bit hotter. They'll run a lot faster. They're getting paid. I'm not sitting here getting paid to do a job, so I can go a little bit slower.
Fair enough. So we have our 4 errors. Why don't we run a clean one and show everybody how it all comes together?
Yep. All right, I got a puddle established. I'm going to introduce the filler rod right at the leading edge of the puddle. Move, dip, move, dip. Keeping my filler rod in the shielding gas envelope and dipping the leading edge of the puddle.
Other than that, you got your material nice and clean. I can see that. You got your tungsten sharpened to a nice point. You got your gas sorted out with the gas lens kit, flow meter, 20 CFH. You're as close as you can without touching. Smooth movements all the way through. You're at the right amps for the thickness of the material that you're working and the speed that you're working at. And other than that, Mark, it just looks like move, dip into the leading edge, move, dip, move, dip. Yeah, that's it. Now you can see I'm coming up to the edge here, or to the end of the weld. So I'm going to dip my rod in a little bit, cool the puddle down, give a little there, and then I'm going to hold my torch right here. So there you go. Once I let off the pedal there and cut the arc, I'm just going to hold my torch in position, let that post gas flow right over that molten piece as it cools. So Mark, I'm sure you're happy with that weld. I think that's a pretty good looking weld. And I think that goes to show just how simple it can be. If you practice the fundamentals, those couple basic errors, and you get all that dialed in, how simple TIG welding can be, right?
That's exactly it. You practice them, the muscle memory comes there, and it's just a matter of doing it over and over.
Yeah. What do you see when you look at that weld?
I mean, there's far better people that TIG weld than me.
Fair enough.
But it's structural. It'll get the job done, and I'm happy with it.
Cool. Well, that's all well and good, but let's get to the good stuff here. Can you give me your tips and tricks for aluminum?
Sure.
So how do we set the machine up, first of all?
Very easy. Switch the unit to AC.
Pretty simple, right?
As easy as
Around that,
Yep.
we have our other basic controls, but I know clearance effect in the top right. That has to do with aluminum welding.
Yeah, and what that is, you're going to find on some machines, you'll hear it'll be named balance. But what that is in the AC sine wave, that's going to determine the percent or amount of time where you're more positive or more on the negative side. That'll give you either deeper penetration or a wider. This machine is very easy to set up. You have your zero, your neutral in the center there. I run a little bit to the -1 side right there.
Gotcha.
And what that does, again, because I'm a little bit slower on the welding, that gives me the penetration I need on there to weld a little bit slower. Some guys will move, they'll go a little bit harder, deeper on there,
Right.
go a little bit faster.
Right.
Wider is just depending on different joints or material where you need a little bit more cleaning effect into there. So very easy to set up. I'd say for practicing, start at the -1 right there.
Perfect. So let's run a bead. Let's see how it's done.
Yeah, okay.
So Mark, it looks like a lot of the basics stay the same, right? You want to have good torch control, good amperage, good gas flow over the weld. What is different with your technique when it comes to aluminum?
Yeah, there's two main things. Because of the thermal properties of aluminum, what's going to happen is as you come down into more of your piece, more of your weld, you're going to get a heat saturation a lot quicker in aluminum than what you will in steel. So,
Right. That's why they make heat sinks, fins, that type of stuff out of aluminum.
Yes, correct. So what you want to do there is your puddle is going to start running away from you. It's either going to go deeper or wider. So you can let off on your pedal a little bit. Or what you could do is you could feed rod a little bit more. This will actually cool the pedal in there.
Right. Start to speed up a little bit.
Yep. The second thing that, and for starting out, that you really want to do is keep that rod where I have it now. Not over here. Don't be waving it around. Keep it in that envelope of that shielding gas and near the heat. What that'll do is that'll keep for these hangers. This is going to melt very easily, so you'll get, if you're too far out, you'll get a little hanger on there. Then when you go to dip that, you get contaminants and you got this problem in the puddle. But really, that's it. Same four properties that we learned on the steel. Just watch your heat a little, and then keep practicing.
Right on. So why don't we dive into some of the common errors for aluminum?
Okay. All right, with aluminum, what we talked about is prep. Number one thing. There's an oxide layer on there. It takes about 3,000 degrees F to burn through that. The aluminum base metal is going to melt at about 1,100. So if you don't get rid of that, you start your torch there, you just keep dialing up more amp, and all of a sudden you burn through, blows a hole right through it. Stainless brush, you want a dedicated brush, but you want to take
aluminum brush, right? Stainless brush?
Stainless steel brush.
Stainless steel brush dedicated for aluminum.
There, yes. All right, I didn't say it right. Yep. So you want to go ahead, keep scratching at the weld area until you're through that oxide layer.
Right. So it seems like aluminum is a little bit more temperamental than steel, right? The prep is just that much more important.
Yeah, cleanliness.
Yep. Right.
So I can go ahead, show you what it looks like striking an arc on the oxide layer and what can go wrong, and then we'll do one on a properly prepped area and what that looks like.
Sure, let's take a look. Man, you could tell right away when you moved over to the oxide layer, that black ring formed around it. You even have like a little bit of discoloration in the metal there, right?
Yeah, you have something going on. Picked up something there that, as a green. It's not just the typical black. But yeah, this was off properly prepped, and got the puddle, moved that 3/4 inch. But this one, you can see I just had to continue to burn and put heat in it. I was full throttle on the pedal, so I was getting a little bit closer to my substrate, which increases your amperage there. Right. But still, you can see how it's, and the tungsten's.
That brings us to our second error with aluminum, right? Contaminated tungsten.
Yeah. So we can show you how that's going to work with a puddle.
Yeah, let's take a look at that.
All right.
Again, you could just tell right away something was up, right? You got that black ring around. It sounds different too. It doesn't sound right.
Did you notice the wandering? Yeah. I couldn't keep an arc where I wanted right in there. That thing's just trying to go anywhere at once, and that's because you don't have. There's no shape to this. It's not balled a little. There's nothing.
It's not directing.
Yeah. Yep.
Right.
Yeah. So the last two errors that can go wrong, Joe: too cold, too hot, not enough amperage, or too much. So I'm going to show you first what it looks like, not enough amperage. Okay. So when you see this, as you're practicing, you'll know, okay, need a little more. And then next one I'll run underneath it will be too hot. You're going to see how the puddle's going to be wide, it's going to be flat. Then you'll know, all right, too much. So let me just show you those quick.
Cool, let's take a look. So, Mark, I can obviously tell which one's the cold one here. We have one weld that's a little proud, a little thin, a little bit tight together, and one that's nice and wide, right? So what do you see when you look at these two?
Well, like this one here, this one was too hot. It was, you could see it's concave in there. I had to push a lot of filler into it because it just kept trying to fall out the bottom one there. So that's not too good. If that were on a joint there, that probably would have fell through.
Yeah.
Too cold. Is easy to tell. It's just that worm right on top there. And you noticed in the close-up, these little balled up pieces of aluminum here, that was from the rod in there. Just not enough heat to even keep the rod warm enough. You'd get close to it, you get that little hanger, melts off. So that's the easiest way to tell where you are. You don't want it round on top, you don't want it concave on there.
Yeah.
Go right in the middle.
Heat control is something that's so important when it comes to TIG welding, right?
Correct.
I mean, we haven't spoken about it yet, but the foot pedal that comes with the TIG 200 AC/DC, not only does it come with one, which a lot of our competitors don't include a foot pedal, but it's a nice one as well. It supports your whole foot, allows you to be really accurate and dial in exactly what kind of heat you need into your piece.
Yeah, it's a real nice rocker pedal, and another benefit of it is you're still using your machine amperage setup on here. So your foot pedal, if you get your boot caught on the side, you're not hitting the knob, changing your settings.
Right. So on the old pedal, there was a knob on the side. You used to have to reach down, adjust it. This one, when you flip the switch over to foot pedal control, your same power knob that you were using for torch control becomes your foot pedal power control.
Yep.
Right. All right, Mark, so I think we've covered everything. Why don't we pull it all together, run a nice clean bead, and then take a look at what that looks like.
Great. All right.
All right, Mark, so you can tell that's a decent TIG weld right there. Got everything you need. Everything was under control. You did your prep work right. You got your gas dialed into where it needs to be. You got good torch control, and you have your amp set for the piece and the speed that you're working, and it all came together to give you something really nice like that.
All right, so I think we found out TIG welding's not really that scary. You get the right equipment, a little bit of practice, it's not that hard.
Yeah, if you show up with the right tools, like the TIG 200 AC/DC with all the features that it comes with, the gas lens kit, the flex head torch, the flow meter, the rocker style foot pedal, it makes TIG welding really a decently easy job with a little bit of practice, right?
Yep.
And on top of that, the holiday special's running right now, If you pick this welder up before the end of 2021, you get an industry-leading 6-year warranty to come with it, worry-free TIG welding for 6 years. I mean, that's unheard of. And on top of that, free shipping over the holidays, over $199. So act now, pick this thing up. It's a great deal as it is right now, and definitely worth every penny.
Can't lose.
All right, Mark. Thank you so much for joining me today, sir.
Thanks.
Subscribe to our YouTube channel. We're giving away a MIG 180 welder at 500,000 subscribers. Also, check out our channel as well. We have tons of great TIG welding content over there you're definitely going to want to see. We'll have the TIG 200 AC/DC link below. And as always, thank you so much for watching. I'm JD. Make sure you keep it right here at Eastwood to do the job right.